that in fact he had to have an electronic circuit, which we call the voltage intensifier circuit, that gave us the ability to switch off the amp flow and allow the voltage to take over in a dead short condition. Now, in all probability, if he had had this knowledge, then we'd have been on hydrogen many years ago. Now, the point out about potential energy on voltage, to give you an example of this, is you go home and you turn on your TV set or your computer monitor, you're adjusting the B plus voltage potential behind the screen, and as a result, you're now accelerating the negative charge electrons coming off the gun, and that increased velocity of the negative charge electrons striking the fluorescent material now produces a greater light intensity. We know also, like in a cyclotron, that if you use opposite electrical fields, you now can accelerate particles in a 2 or 3 mile area tunnel, and as a result of this, you can accelerate these particles close to the speed of light, and those particles hit a photographic plate, and that's how physicists study matter. So we knew, in fact, that voltage does, in fact, perform work. But heretofore, no one ever dreamed of applying it to switch off the covalent bonding of the water molecule and do it in this way and do it economically.
It was always thought in the past that current did the work.
Right, always current, and they would always, because Faraday, he needed modern-day electronic circuit designs capable of restricting amps and all voltage to go over. He worked with a very crude battery, and he worked with just an electrical wires going into the beaker with chemicals. So he created a dead short condition, and when you create the dead short condition, you cannot bring voltage up. Voltage remains low, and amps take over and does the work. All right, so this is why Faraday did not discover the electric polarization process. Now, in order to come up with the economic way of doing this, then the Lord had me develop what was called the VIC, or the voltage. It's called the voltage intensifier circuit. Which gave us abilities now to restrict the amps and allow voltage to take over. Now, as you know, or who's electronic people in here? Oh, praise the Lord. Okay, whenever electronic people can understand this far easier than physicists. Physicists deals with strictly the nucleus of the atom, and electronics deals with the movement and deflection of electrons, and that's exactly what we're talking about: moving and deflecting the electron. And in an electronic circuit, it's clearly proven by Coulomb's and Newton's second law, you can use electrical force to move electrically charged particles in an electronic circuit. Is that not the basic basis of electronics? Yes. Okay, so we're not defining the laws of physics in order to accomplish the task. Now, whenever you put a dielectric liquid between two electrical conductive plates, what do you got? You got a capacitor, right? So we know that when you take a coil and hook it in series to a capacitor, you now develop what's called a resonant charging choke. So now I've set up two charging chokes on opposite side of the capacitor. And I'm now allowing the water and the properties of water now to become the property or the component part of the electronic circuit. So we now know that on a resonant charging choke, that when I put in a switching diode in here, then as I would pulse the circuit, then these coils would become energized, and they would create an electromagnetic field which acts as an electronic choke, right? The electrons coming off of here has an electromagnetic field, and as a result, when these coils develop their magnetic field, it now chokes off and prevents electron flow from occurring. So since the diode now is acting as a switching diode, once you terminate the pulse, it opens up the pulsing circuit and now allows these magnetic fields to collapse. And when they collapse, now we're producing a unipolar voltage field across the capacitor, but in the process we are restricting amps. Now note, we are using the electromagnetic field to restrict the amps, not a resistive element. If you have a resistive element, you're consuming power.
I know one thing that was noticed in your circuit diagram is that you were using a resistive choke.
Or is that a mistake?
Or is that in your actual...
No, in filing the patents, I filed them in several ways. They said, well, I use it this way. You have a hard time to get around it, because not only have I filed the patents on the particular technology, but I filed patents in all of its related area to give me a technological buffer zone to be able to ensure that I can bring the technology in.
So in other words, that resistive choke that you've got in your...
It's not necessary.
It's not necessary? You says, where the hell is it? Yeah, you say here, resonant charging circuit, resistive coil wire.
Yeah, you can put a resistive wire with the coil. So some intelligent guy is going to say, well, I got a copper coil, and one says, well, I'm going to use a resistive wire. Well, sorry, folks, I got it both ways.
Oh, I see what you're saying. Just to get around the patent. It's just people might use it to get around the
Yeah, I mean, a guy invents something and say, well, all I'll do is I'll change something on the patent and try to get around it. Okay. Well, this was developed under the KISS method. Keep it simple, stupid. So the simpler it is, the harder it is to get around the patent. And of course, when this knowledge was coming forth, it was fantastic for us because I knew that if we kept it simple like this, well, then it would be very, very hard to go. And if you look at all of our patents, you apply a voltage across that water molecule, you violated my patent rights. Okay, now what we're doing is that this circuit is not only now restricting the amps, but we're now pulsing and adjusting this pulse frequency to tap into the resonance properties of water by the dielectric value of water. And as a result, that when you tune into this, then what happens, amperol drops down to the lowest value, and voltage now takes off towards infinity if the electronic components will allow it to occur.
What sort of frequency are we talking about?
Well, we have various frequencies when you can adjust to hit resonance. The key was to go from natural water to non-processed water. And so it was very obvious that we've developed the electronic circuitry to interface with this, that we now electronically zero in to the resonant frequency of any form of natural water, because it would change based on the contaminants within the water.
You just let it peak itself.
Right. It automatically scans it right in, locks right in the resonance, and holds it there.
You can't change much.
frequency?
Pardon?
What order of frequency are we talking about? A few hertz or...
No, we go from 0 up to 10 kilohertz. Even with this type of circuit you see here, if I hit this at 10 kilohertz, would this not increase it to 20 kilohertz? So not only is this a pulsing circuit to restrict amp flow, it's also is a frequency multiplier. And guess what else? If I was going to increase more hydrogen gas yield, what would I do?